So we have 2x times the inner function prime. These are gone. Minus whatever this is, I don't care. So this is equal to negative 30 times 12, right? Negative 360 times, how do I differentiate this? It's a function of a function. How do we, what is the cosine prime?
A negative sign.
Times the inner function prime.
D alpha divided by D.
T. Awesome. So now I have to divide by 2x, both sides. I have to change the signs here because there are too many negatives and I don't need them. And then plug in 60. Careful. Okay? So x has to be determined from here when cosine alpha is 1/2, cosine 60. So we don't have x, but we will have that at a particular instant. So let's do that. So first, let's simplify. So this is my page 8. Okay, so I have x dx over dt. This is 180 now. Sine alpha d alpha over dt. Then the next step, I have dx over dt equals 180 sine alpha times d alpha over dt and divide by x. So now this is when alpha equals 60 degrees. Okay. For x, I have the square root of 15 squared plus 12 squared minus, so this is cosine 60, which is 1/2 times the 2 go away, so negative 15 times 12. Okay, so 180 is 180. This will be sine of 60 degrees. This will be the square root of 3 over 2. And this is given to us as 2 degrees per minute. Okay, so let's plug everything in the calculator. Let me share my screen. Let's go to the calculator. And let me clear all this. Okay, so the top. They're all multiplication, but just to be on the safe side, I'm going to write 180 and times. No, I'm going to write 180 over 2, so it's 90. 90 times the square root of 3 times 2 and divided by the square root of 15 squared plus 12 squared. I know what these are, but never mind. And minus 15, because I divided by 2, correct, yes. 15 by 12 times 12. Okay. And I get 22.68. So approximately 22.68. This is the rate of change. What is the measurement unit? And it has to have 2 measurement units. What measurement units? Sorry. What measurement units?
Is it meters per minute?
It's meters per
Degrees.
minute. I have to change the degrees, right? I just said that, and I didn't do it. Times pi over 180. So let's finish it up. They are very good at tricking us. So times pi divided by 180. Okay, so approximately 0.3958, and this is x is in meters per minute, and t is in minutes. Oh, I didn't share my screen. Why didn't I share my screen? Sorry. So times pi over 180. Because they gave us 2 degrees per minute. Any questions? Any questions? Times pi over 180. Is this okay? Any questions here? Can we go on to 3.7? Perfect. 3.7. 3.7, where are you? 3.7. Okay, here it is. Here I selected number 9, but you can select anything you want. Number 9. Why did I select 9? The height of a projectile shot vertically upward from a point 2 meters above ground level with an initial velocity. The formula is given to us right here. Find the velocity. Find the velocity after 2 seconds and after 4. When does the projectile reach its maximum height? Maximum height. When does it hit the ground? With what velocity does it hit the ground? Is it a yes? Is it a no? It's up to you. Well, we can choose something else.
Yes, please.
Okay, this one is okay?
Yes.
Perfect. Okay, then 9. This is in 3.9. So we have age of t equals 2 plus 24.5 t minus 4.9 t squared. Find the velocity after 2 and 4 seconds. So we know that the velocity will be v of t, which is h prime of t, which is 24.5 minus 9.8 t. And they're asking us to find after 2 seconds and after 4 seconds. After 2 and 4. Okay, we'll find that with the calculator in a minute. When does the projectile reach its maximum height? So we know that this is a quadratic function and it has a maximum. This is the maximum. When will it reach the maximum? When the derivative is how much at that point?
0.
Yes. Or f prime is 0. Okay. So 24.5 minus 9.8 t equals 0. I move, it doesn't matter, I have to get 24.5 over 9.8. See, t equals 24.5 over 9.8. So I'm going to do all these three now with a calculator. Let me share. So where is it? Okay. So in y equals, I want to plug in I want to plug in 24.5 minus 9.8 t. And I want to, no. I want to plug in 2 and 4. Okay, so 2 and 4. 2 is 4.9, and 4 is negative 14.7. And now I also want to divide 24.5 by 9.8. Oh no, 24.5. I thought I did click. Divided by 9.8, but apparently it didn't take it. Okay, so 2.5. So t equals 2.5, and now let's discover the measurement units. So meters per second. So meters per second and seconds. So these are meters per second because the velocity. Meters per second. Remember, this is the direction, and this is seconds. And now let's go back and take a look at part C. What is the maximum height? How do I find the maximum height? I have the time needed to get to the maximum, 2.4 seconds. But now the question is, how do I find the maximum? And when does it hit the ground? In a minute. That's part D. So how do I find the maximum height? I have the time that it needs to get to the maximum, but now how do I find the maximum?
Plug it into HT.
Yes, age of 2.5 is the maximum height. Good, we'll get back to it in a moment. We'll plug it in. And now we're asked when it hits the ground. When does it hit the ground? What do I need to do?
Set HT to 0.
Of course, thank you very much. Hitting the ground means I am at height 0. Yes, I'll come back and we'll calculate that. So we have to solve 2 plus 24.5 t minus 4.9 t squared equals 0. I don't like it. I will rearrange it. And now I'm going to find the maximum height, and I'm going to put this in the graphing calculator. At this point, I don't expect you to use the Corati formula. I expect you to use the apps directly. Because in calculus, I know you know. Okay, so go to apps, and that's number 9, and then polynomial, and then degree 2, yes. And the first coefficient is 4.9. Yes, I know, yes. Take it easy, slowly. Yes. Yes, that's 4.9. Then the next one is negative 24.5. And then the next one is negative 2. And has to be in descending order. Okay. Okay, so we get x, so t equals negative 0.08, which is not possible. So it hits the ground at t equals 5.08 seconds. And also, I want to put the function in, which was 2 plus 2, 24.5, and then minus 4.9 t squared, and I want to put in 2.4. Okay, so with 2.4, the y value for the function. Oh, why did I put 2.4? Nobody knows. Why did I put 2.4? Okay, so we were finding the maximum height. Nobody knows what I did here. Ah, got it. It would help if I would enter the correct function. Okay, so it's 32.625. So maximum height 32.625 and the measurement unit in meters. Okay, good. When does it hit the ground? We know at 5.08. With what velocity does it hit the ground? How do I determine that? Knowing that I have the velocity function and I know when it hits the ground. I have the time, so the time equals 5.08 seconds, and I have the velocity v of t 24.5 minus 9.8 t. So they're asking us, what is the velocity? So all I have to do is just plug it in. That's why I put it in here, so I don't have to do it again. So here's the velocity. This was the velocity. So the velocity at 5, okay, so I plug in 5.08. 5.08. And here's the velocity. Of course, it's the direction, negative 25.28. So v of 5.08 is negative 25.28 and is in meters per second. Let's go back to 3.6. In 3.6, I selected, and you can change that as you like, I selected 39, 53, and 66. 39. Find the equation of the tangent line to the curve at a given point. I selected 53. You can select any, feel free. And I selected 66. Which one do you want to start with?